experiment number 4. The title of the experiment is Determination of Solubility and Solubility Product of a sparingly soluble salt at room temperature, and the method that we are going to use is a conductometric method. In this experiment, we are going to use barium sulphate as the sparingly soluble salt, and we are going to dissolve barium sulphate in water and study a chemical equilibrium of its dissolution in water at different temperatures. So, here is the chemical equilibrium that we are going to study. Barium sulphate, when put in water, will dissociate into barium 2 plus and SO4 2 minus. Barium sulphate, as we have already mentioned, is a sparingly soluble salt. Therefore, when this chemical equilibrium is established, we shall have in the medium not only barium 2 plus and SO4 2 minus, but also substantial concentration of undissociated barium sulphate. Our basic idea is we are going to study this chemical equilibrium at different temperatures and from there obtain important information regarding the solubility product and the heat of solution of this salt barium sulphate. In this particular experiment, you are going to obtain for every chemical equilibrium the conductance of the equilibrated mixture, and your observation would be as you are increasing the temperature at which the system is allowed to undergo equilibration, the conductance value would increase. This information can be translated back and we can find out the solubility of barium sulphate at a given temperature. So, if I plot temperature along the x axis and solubility of barium sulphate along the y axis, then typically these are the experimental points that one obtains by varying the temperature from about 25 degree centigrade to 60 degree centigrade. And then one can draw the best fit straight line through these experimental points, and from here we can find out what would be the solubility of barium sulphate at the temperature of the laboratory when you are carrying out the experiment. So, the message that you get from this picture is solubility of barium sulphate increases with increasing temperature. Now, from Le Chatelier principle, it is expected that this system would be an endothermic reaction. We are going to determine the heat of solution from this chemical equilibrium and see if this equilibrium gives us any insight into the endothermic nature of this dissolution process. For this purpose, you are going to use the solubility values to find out Ksp, that is the solubility product. Take a log of that quantity and plot it as a function of inverse of temperature expressed in degree Kelvin. So, this is how typically your data would look, and if you draw a best fit straight line through these data points, you can find out the slope of this straight line, and from the slope you can find from your knowledge of thermodynamics the delta H value for this reaction. As you would see that delta H would be positive, which is a hallmark of an endothermic reaction. Therefore, in this experiment you are demonstrating the effectiveness of Le Chatelier principle, and you are also predicting the solubility and solubility product of barium sulphate at room temperature, where you are carrying out your experiment. And finally, you are determining the heat of solution of barium sulphate under the given experimental conditions.
Here I will explain the stepwise working procedure. Step 1, the very first step. You have to prepare barium sulphate solution. Preparation of barium sulphate solution. Barium sulphate is here. You have to take a pinch of this, pinch. This is the spatula. This much is enough. Then you have to put it inside this water jacket beaker. This much. Then you have to add 100 ml, roughly 100 ml of water in this. Then you have to put a magnet inside. Then you have to start the magnetic stirrer. To prepare the solution, you have to stir the solution for at least half an hour. So this will be on for half an hour. In the meantime, you can go for step 2. Step 2 is measurement of specific conductance of distilled water at different temperatures. You have to measure the specific conductance of distilled water. So you have to use this water jacket. This is for measuring distilled water, conductance of distilled water. You have to take roughly 100 ml of distilled water in this. Then you have to put the cell inside. This is the cell. You have to put the cell inside in this way. Then this is the temperature probe. You have to insert the temperature probe very carefully. Next, you have to make this one ready. This is the instrument using which we will measure the conductivity of the solution. So this is conductivity meter. Model number is 306. To measure the conductivity, first of all, you have to calibrate the instrument. Calibration. Calibration to be done with KCl solution 0.001, 0.01 and 0.1 normal solution. But to save time, this part of the experiment is done previously by the laboratory personnel. So you need to do the calibration because this takes a lot of time. So to save time, we have calibrated the instrument. You can get the reading directly from this meter. Now this meter, as soon as you put the switch on, this will show a stored data. Now it is showing 1.1. This 1.1 is the cell constant of the cell. You know what is cell constant? L by A. It is showing the cell constant of the cell 1.12. So you have to note this one down. Okay. You need this cell constant in your manual. You have to write down the cell constant of the cell here. Next, you have to push the cal switch. If you want standardization of the instrument, then you have to put write yes. If it is no, then you have to write no. So abort. Next, this display will come put solution. The cell is inside the liquid. So this thing is ready. You can push this knob. It will show busy. Next, it will show the reading of temperature and conductance of the solution. 27.0, this is the temperature of the solution, and 5.406, this is the conductance of the solution. Unit is microsiemens. So the conductance of this solution is 5.406 microsiemens at 27 degrees centigrade. Okay. So you have to start from 25 degree, then you have to lower the temperature of this one. You will get the conductance at 25 degree. Now it is showing 27 degree. The first reading, you have to take the first reading at 25 degree. So you have to lower the temperature of this one. Okay. That's a different method. If you add little bit of cold water to the solution, the temperature will go down and you will get the reading at 25 degree. The next reading you have to take at 30 degree. 30 degree. You can start this unit. See, this unit, it is the temperature controller unit. Now this temperature of the liquid inside is 36 degree. It is showing 36 degree. If you start the pump, the water will flow and the water will go inside through this, and the temperature of this unit will raise. Okay. So let us start this pump. Now the pump is on. So hot water is coming through this pipe. You can see what is coming through this and going out from this. Okay. So the water jacket, the liquid inside the water jacket will get warm and the temperature of the solution will get raised. So when you find the temperature is 30 degree, you have to note down the second reading of conductance here. You have to take 1, 2, 3, 4, 5, 6, 7 readings total. Okay, 7 readings at an interval of 5 degree centigrade. At 25, 30, 35, 40, 45, 50, 55. After taking the last reading at 55, they have to measure the conductance of barium sulfate solution. That is step 3. Okay, barium sulfate solution. Within that time, see, it will take more than half an hour to get this reading. Within that time, the solution will be prepared, and you have to take the reading of that particular solution. You have to start from 55 degree. Okay. Then we will start the cold unit. The temperature will go on decreasing. So that you have to take the next reading at 50, then 45. In this way, you have to go up to 25 degrees centigrade. Okay. So now see. Now it is 29.5 degrees centigrade and the conductance is 5.868. Okay. So it is showing a different conductance. Now it is 29.9, now it is 30. Okay. You have to note down the conductance at 30 degrees centigrade. I will show you how to take the reading of barium sulfate solution. See, after this solution is prepared, just after half an hour, you have to put this magnetic stirrer off. Then this unit, the cell, the temperature probe and the lead of this as a whole, you have to shape this to this water jacket. Okay, in this way. That means now the cell is dipped inside the barium sulfate solution, prepared barium sulfate solution. The temperature probe is also inside in that. Now you have to do some change here. When you will change the solution, You have to abort from the previous one. So, you have to press the abort switch. Now, it will show put solution, instruction is put solution, then you have to press conductance again. Now, it is showing the reading. Now, the temperature is 36.2 and the reading of conductance is 40.99. Unit is millisiemens. So, the conductance of the barium sulfate solution, the prepared barium sulfate solution is 40, now it is increasing as the temperature is increasing. So, it is also increasing 41.27. So, you have to note down the conductance at 55 degree, 50, 40, 45, 40, 35. After taking the last reading, you have to take the cell out, you have to put this switch off, conductivity meter, then you have to take the cell out first, then you have to wash the shell in distilled water in this way. You have to wash the distilled water here in this way outside. After washing, you have to keep the cell again in distilled water. You have to take the temperature probe out, then you have to wash the temperature probe with distilled water. You have to put the lid of the beaker in this way, then insert the cell and then insert the temperature probe. Whatever left inside this water jacket, you have to throw that out. Okay. Then you have to wash the inside of the beaker and you have to take the magnet out. Yes. So, the readings are taken and the cell and the beaker has been washed properly. After washing, you have to throw the liquid here in this container. Okay, this container is meant for that. And you have to arrange everything properly on the table and you have to return the magnet to the laboratory personnel. So, this is all about the experiment. Now, you can do the experiment yourself. Thank you.